everyone. This is chapter 8. I'm going to talk to you about, this is the last chapter for the semester. And a couple of things I want to talk to you about is, before we get, this is probably the beginning of data structure. The heart and soul of computer science, pretty much with it. I want to just to recap some of the things that we talked about, and everything that we do up to this point is basically it's pulling in from the data structure for this course with it. Just to backtrack here, I want to pull chapter 2 slides. If you recall, in chapter 2 slides, there were certain things that I want to point out as the basic of the C++, and one of the things is the things that we talked about, the data types with it. So I want to point out the slide. This is a slide back in slide number 17 in chapter 2. That if you recall that there was 3 types of, in C++ data types, it falls under a simple data type, there's a structured data type, and there's a pointer in there. And in the integral is what we've been dealing with all this time with it. And one of the things you get into, the different integrals and floating points and enumerations with this. This is where we get into and talk about the certain structure data type is the pointer data type that I'm going to talk to you about right now. Is to things that the way how things are manipulated into arrays. You get into certain things with it. So bringing it back to hit home. In this chapter, I'm going to talk to you about learn how what is an array, what is how do you declare and manipulate arrays data into an array. Learn about what does it mean when an array index is out of bound, and learn about the restrictions on array processing and passing an array through a parameter to a function. And we're going to talk about search and sort. We're going to talk about things more about the C string. If you remember that you did somewhat of manipulation of C strings with it, using some of the strings function processing and some of how you process C strings with it. So we're going to get more into this thing as well with it. So before I get to, I'm not going to read the structures with you, but if you recall, the simple data type variables of these data types can be stored only in one variable at a time. You had your int, you had your double, you had all these data types. If you recall, back in chapter 2, they are only one storage to a variable at the same time. In an array that we're going to look at is a structural data type, a data type in which each item is a collection of other data types with it. So this is like an array of everything in this array. Couple of things I want to, before we get too far with this thing, building up from chapter 7, arrays are all reference parameter, first of all, with it. If you recall what reference parameter is, when we had an ampersand after the data type in the formal parameter. And you remember in the functions, you had 2 types of functions, their value and their void. And in the void function, you can actually assign certain ampersand to after a data type, saying it's a reference address. And I talked to you what's a reference address. It's an address of that location of that memory that's being stored in there. So what does that mean? So in an array, it's by definition is a collection of fixed number of components, all of the same data type. So it's like a container. I'm going to use this analogy, such as a tennis ball. So a can of tennis ball, for example. I'm just pull up a little Google just to describe what I'm talking about in here. So let's say I pulled up image. I want to say a can of tennis balls. So if you take a look at this picture of the can of tennis ball, and just grab this can right here. This is a can of tennis balls. It has 3 balls in here, all 3 the same balls. There isn't anything that's different from one ball to another. I can't have a baseball in here. I can't have a golf ball in here. So it's basically one variable, one memory address. It has all sorts of positions in this thing. So if you look at this one variable, that I can actually store multiple containers in this thing, and the sizes of that, I can do pretty good actually. Okay, so that's what this is about, is studying about arrays. It's a one-dimensional array. A list of components are arranged in list forms with it. So if you have like a to-do list, a shopping list, these are things that you can actually do as a one-dimensional. We're going to start with very, very elementary type of stuff. It's basically one-dimensional arrays with this thing. The syntax for declaring a one-dimensional array is the data type, and the name of the array, and the size of the array, int expression with this thing. So this is the basic syntax with the int expression is any constant expression that evaluates to a positive integer. You cannot have a negative array with this. So arrays are always a positive and has always to be an int. It can't have half an array, can't have a decimal array with it. So if I said data type is an int, array name is, let's say, list, for example, and I have a list size 5. That means that I have 5 things in my array. The other point I want to make is about arrays. Arrays, by definition, starts out with element 0. If you recall in strings, we start out, if I ask about positions, you would start out with element 0 counting. If I ask you the length of a particular string, you would start counting with 1. So that's the type of stuff that you're going to see that's coming across similar resemblance that we talk about. It's just some definitions we talk about here. So let's take a look at this thing. An expression with a non-negative integer value with this thing. So if you have a square bracket, you see these square brackets there here, array subscript operator and array index always starts with 0. This is by definition. Remember this. Keep this in hand with this. A value of the index is the position of the item in the array with this thing. Okay, so this is an example. Here is an int list 10. If you notice here, it starts up by definition. Its element is 0, and this is the container. It goes all the way up to 9. There are 10 places that you would actually place in here. So for example, if I want to set 34 inside of element 5 in this list, 34 is equal to list element 5. That puts it in there. That allows me to write it. Key things to make a note here. I mean, how you access the array and what you read and what you write is very important. That's accessing an array. I mean, if you think about an Excel spreadsheet, I'm going to use an analogy. I'm going to toggle it here. I'm going to open up an Excel spreadsheet for you to see what I'm talking about. So let's say I pull up an Excel spreadsheet in this. And you have, if you kind of imagine, here is a one-dimensional array. It's basically a list of things that you are doing. And when you have an Excel spreadsheet, each one of these cells have an address. So it's containing by what? If you look up here, it's in the letter IJ. Letter, column, and location of this is the actual address of that cell. Very similar to, this would be considered as a two-dimensional array if I had to do this array. You know, a spreadsheet is a two-dimensional array inside of this. So as you can see, it goes, if you have one-dimensional array, we have two-dimensional array. You also have three-dimensional array, which involves your Cartesian coordinates in here, your XYZ coordinates in here. You don't have to worry about anything about three-dimensional, more anything than three-dimensional array. This course only covers up to two-dimensional arrays. That's it with it. But it's for the computer science guys that later on, if they want to actually study computer science, you get into more data structure involvement with it as well. So this is an example of how I refer to an Excel spreadsheet with this thing. So inside of this thing, as you can see, if I want to actually take the content of 6, add that to the content of 3, list 6, add that to list 3, have it put in list 5, meaning store it in list 5. I can do that to do certain memories with it. Again, the key thing is it starts with 0, and data types have to be all the same. And the third thing is you cannot change the size of the array. If the size is 10, you dictate it as a size 10, you always have to remain size 10. Okay, so that's the type of stuff that you have to realize about arrays with it. Basic operation on one-dimensional array: you can initialize it, you can input it, you can input data into it, you can output data, store it in an array, finding the largest or smallest. This is the basic operation for a one-dimensional array. I'm going to do something like this with you in one of the programming problems. Hopefully later on you can see what I talk to you about. Okay, hold on.